How to win the ISEF Grand Science Fair. You want to go from your local science fair all the way to winning the ISEF Grand Award. And today I'm going to give you the exact playbook, ideas, execution, and presentation, plus 5 recent award-winning ISEF presentations that will help you win right now. But before we dive in, if you want professional coaching directly from me and Jack Anderson, check out our website, Ivy League Consults. We help students craft publishable research, win national competitions, win science fairs, and build the exact profile that top colleges want. Click the link in the description, and you can go to ivyleagueconsults.com for more information. My name is Oliver Hammond. I recently graduated from Harvard. I'll be doing my MD PhD over at Yale University, and I've spent over 10,000 hours doing research. I published over 30 papers in top medical journals, including Nature, BMJ, and many other top journals. And I worked on everything from blood cancer genetics to AI and healthcare. I even TA'd a course called Data Science at Harvard Medical School. So I know what I'm talking about, and I'm the right person to help you guys do the same. But most importantly, I was exactly once where you guys were. I was a student trying to figure out how to get into science fairs, how to stand out, and how to publish my research. And now I want to give back by breaking down the exact strategies that actually help you guys get noticed by ISEF judges. Now, remember, ISEF isn't about luck. It's about strategy, a novel idea with real-world impact, rigorous data, and a crisp story. If you can explain your work in 30 seconds, 3 minutes, and 10 minutes, you're already ahead of the game. Now, the most important part about winning ISEF is picking the right project. There are 3 main things that I'm going to start off and help you do. The first thing you'll want to do is pick a project that has novelty, something that solves a new problem in a new way. The next thing is impact. It has to matter for the society, for medicine, for technology, or for the environment. And you have to have tangible metrics of how you've been able to show that impact. Finally is depth. It's not surface level, but you've really dug into the science. You've done the experiments, you've shown them, you've done the analysis, and then you've really shown that your project is truly solving an issue. Okay, now that you've got an idea, execution is everything. The judges want to see rigor. This means that enough trials makes your data statistically solid. Clear results, real analysis, not just nice aesthetically pleasing charts. They really want to see that you've dug into the science and you have tangible metrics to show that. Now, the next really important thing is user interface. The judge should be able to really follow your logic in a matter of 10 seconds. If you can follow it in 10 seconds, you can win in time for deeper questions. So make it clean, minimal, and easy to follow. Your poster is really the most important thing. And your flow should really be on the order of problem, gap, hypothesis, methods, results, limits, next steps, and then finally impact. But remember, you are a storyteller. You need to practice your pitch so you can explain your projects in 30 seconds, 3 minutes, and 10 minutes, right? Because you'll have to go through subsequent rounds. But one thing that we often see in all winners is passion and resilience. Judges can tell when you're really, really passionate about something and you're not just there for the medal, versus you've actually poured your entire soul into solving a problem that really matters to you. Okay, now I want to take a look at 5 award-winning projects and actually how they've been able to do them. Okay, the first one is coming out of Yang Wang in 2023, which is a bionic inchworm robots for cables. So the novelty really here comes out of the biometric inchworm-inspired locomotion, which enables navigation and can find cables through a pipeline system. So unlike inspection robots, it really combines this idea of adaptability and minimal energy use with clear applications of infrastructure maintenance. So the project is really interesting and it's really novel and actually applies to the intersection between AI and medicine, which is a really big topic in a lot of these science fairs. Number 2 is self-supervised 3D motion in 2021, coming from Michelle Hua. Breakthroughs in self-supervised learning with geometric consistency is something that is really interesting because it can reconstruct human locomotion without large data sets. And that's exactly what Michelle did. She had this approach which reduced dependence on costly annotations while achieving high fidelity in 3D motion capture. In other words, she was able to actually recapitulate how humans would move without using labels. Number 3 is Bioplex for Monkeypox Evolution by Savik Kanan in 2023. So this project introduced a computational framework for monkeypox viral evolution. It mapped how the mutations evolved and had looked at things like drug resistance and impact infectivity. This is really novel because it linked AI, medicine, and genomic surveillance. And so we could actually see how things like monkeypox viruses would actually evolve over the years, what new mutations would accumulate, and it brought in something new into the question, and something that, in this case, Savik was really passionate about. Coming in at number 4 is Claudin-5 as a biomarker for suicide. So this is a project coming from Natasha Kulivat in 2023, where she looked at one of the first studies to connect the blood-brain barrier junction to these tight junctions with suicide risk. So she looked at this biomarker called Claudin-5, and she looked at things like cytokine profiling and molecular docking to really understand what was the therapeutic potential behind these targeted therapies. And so if you can do some similar project where you're looking at these specific biomarkers and you're looking at predictive capabilities for these different projects, that's something that's really interesting for the judges, but also a very novel project for yourself as well. The very final project is synthetic DNA engineering with iCore, coming out from Rishabh Jain in 2022. The novelty here came from using deep learning with codon optimization, have a heuristic approach to understand how we can maximize protein expression in E. coli. And so it was a really interesting project, especially because it maximized the protein expression, so you can think about things like vaccines and therapeutic production efficiency models. And so having any sort of intersection with deep learning and these sort of basic science wet lab projects is really what's the next step for a lot of these science fair projects. Okay, now the step-by-step for how you're gonna get to an idea actually to a science fair project that will win ISEF. So number one is you need to talk to a research mentor. You should have 3 topics that you're truly excited about and 1 skill you can offer, whether that's coding, statistics, wet lab, or literature review. Then you should identify 5 or 10 research mentors. These should be professors, teachers, or people that have actually won science fairs that can actually coach you and help you through it. The next thing you should do is you should cold email these mentors, tell them what your skills are and how you can be of help to them. If you want the exact email that I use to do research during this stage, email me and check the link in the description. Now that you've identified your topic, the next thing you'll want to do is draft a 1-page plan. This should talk about the background of the topic, what's known, what's the gap, a research question, and the hypothesis. Now the key here is really making sure that your research question is clear and easy to follow and has an actual question that can truly produce tangible results. You should have things like methods, milestones, and success criteria. The next thing you'll want to do now is to choose your data set. There are a number of data sets you could use. If we're talking about biology, there's GEO, SRA, or NRA. These are all omics-based data sets. If you're talking more about cancer, there's TCGA or GDC, PhysioNet, or the MIMIC dataset. Now, if you're more into neuroscience, there's the Open Neuro dataset. Virology or genomics, you want to go with the NCBI virus dataset. Medical imaging has a lot of great ones like SIM datasets or RSNA challenges. For general machine learning datasets, you'll want to go with the Kaggle dataset, UCI, or data.gov. And finally, for public health, you'll want to go with the CDC, the WHO datasets, or the CDC Wonder datasets. These are a number of great datasets that allow you to do a lot of exploration and can actually build fantastic projects just from these datasets alone. Okay, now that you've identified the dataset, the next thing you'll want to do is build your first real model. The idea is really to start simple here and then sort of build on and add more features as you go. And then once you finish that, you really want to validate like a scientist. So making sure that you can validate your results, running a lot of follow-up experiments, and once you feel like you have a really good grasp on your problem, it's time now to start on your poster. Your poster should have several sections. You should have an intro section, a method section, a results section, a limitation section, and finally a conclusion section. The idea here is really to discuss this with your mentor very closely. First, start off at your local science fair, and once you've progressed past that stage, you'll want to go to the semifinalists or the regional round for ISEF. And finally, once you've made it past that, you'll be at the finalist stage. And if everything goes well, you'll have theoretically won ISEF. But remember, this is a long process, and at the end of the day, you should be focusing on the science and the research itself. There is so much to learn here, so much to grow from, and it's really a fun experience. So enjoy yourself throughout the entire journey and follow along for more tips. Thanks for watching. My name is Oliver Hammond. Until next time.